Thanks for turning on your microphone. Oh, there are comments here. I'm new to the live view kind of classroom, so we'll see how that goes. Maybe have a couple of your other professors, right, teach live, or is that not true? No one wants to unmute because you're listening to.
That is correct.
Thanks. Thanks, guys. Good. All right. So you guys are experts. I'm not. I'm more of the pre-canned lecture series. All right. Today it's 11:30. All right, we can get started. I will share my screen. Come on. Actually, I'm going to move you guys to the side. I'll share that. All right. Okay, hopefully you can all see that. This is the, I guess, my review piece today, and we've got the exam coming up on Friday. I may do multiple choice on Blackboard, but the longer answer ones will be standard looking tests. You just have to download and then upload your solutions to it when you're done. And I think the other professors have done that previously as well. So hopefully you're familiar with that, and scanning in stuff on a deadline isn't gonna be too scary. Feel free to chime in at any point. All right. If you've got an accommodation, what's that, Andrew?
Are you just gonna like have us like write out our problems and like how we did it, and then just send you pictures of it then?
Yeah. So in I gave one Monday, I guess, to 354. I think it's the same way Professor Polito did it. I guess you don't have him this semester. I have an assignment on Blackboard, and when you're done, you just the test becomes active at the start time, and you can download it. And if you've got a printer, you can print it out and write it on the sheet, and then scan it in and upload it back to that. Upload that back to that assignment, and so Blackboard tracks what time it comes in. Or if you don't have a working printer, or you'd rather just do it on your own scratch paper, just do your answers on the scratch paper and upload that. Take pictures of it or scan them in and upload it back to Blackboard. So is that what you've done in the past?
Yeah, normally. I just feel like, and I think Nathan asked with timing, sometimes you need a little extra time to do that to get it in on time. So yeah.
Sure. Yeah, for 354, I gave an extra 10 minutes to handle the download and upload issue. And one of the students was worried. He says his uploads don't work well. I don't know what his internet capacity at home, I guess, isn't great. So he emailed me the pictures first, as well as uploaded them to Blackboard, just to make sure they're in on time. So if you've got internet issues, let me know and we can work something out. Maybe. Hopefully uploading the scans shouldn't take too long, right? Shouldn't take a lot of bandwidth. But have you done other tests like this?
Yeah, we have. So yeah.
All right. So you guys are old hands at it. Good. Any troubles trying it this way?
I mean, I can only speak for myself. Sometimes the uploading gets weird, so I'll just email it. But okay. As long as that's an option too, it should be good.
Yeah, that's an option too. So yeah, that covers it. So I guess it wasn't just the one student who had that same issue on the last test through that. Well, how's the exams been going?
I think there's a little bit more difficulty being focused and being productive in this environment. So a lot of professors assume that we'll get more done in the time than actually happens.
Okay. So, yeah, I don't know. My production isn't very good at home. I don't know about you guys, but yeah, anyway, the dog always wants to go for a walk or something, and kitchen's too close. So yeah, in general, my production is lower through that. So obviously this is going to be an open book / open everything test, right? Since there's no way to really do it otherwise. through that. It'll be similar to the last test in general. I like the concept questions at the beginning, multiple choice usually, for concepts. And then we have longer answer calculation ones through that. And I'll probably have 15 or so, maybe 20 multiple choice questions, and they're usually worth 2 points apiece. And that's usually where this ends up. And then the last part of the test, at least 60 points of it's going to be long answer, working out calculations. And so that'll be partial credit on that, which I think is usually a plus. You've had one test with me before, which is also open book. And so you know a little bit what to expect. And I'm guessing you've had other open book tests now since you've been online. So you may be in the groove a little bit more in how these look. Is that correct? I'm just staring over here to see who unmutes themselves enough to talk. Nope, no comments. All right. If you guys write me, there's chat, the chat box. All right. I didn't have the chat up. All right, now I'm reading your chats. Great. Multiple choice for partial credit. I've never done that before. They're only 2 points apiece, so I would tend not to go that direction on that. And a lot of them are just, true, false, and stuff that's kind of mixed in there with it. That'd really be hard to show any work on, right? So I'd like to keep it consistent across all the multiple choices. So I guess I won't be doing partial credit on those. So those will be all or nothing, 2 points a shot on those. There's always a time crunch. Yes, there is always a time crunch. I'll probably lighten it up a little bit since we're online and just things are weird on that. Question for you guys is, our class is 11:30 to 12:20 typically. We can add time on to it if you don't have a class before or after. And I know back in the real class environment, you had chemistry before, and Professor Reich had a class right after us. And so we didn't have extra time to add on to it. So the question is, if people are available to either start early, so like for the 354, I let them start 15 minutes early, and I gave them, I think, an extra 10 minutes at the end for uploading stuff, right? So that gave them extra time. I'm happy to do the same with you guys, but as long as it's fair across the board, everybody has extra time, either before or after. Okay, so Bree says nothing after, no classes before or after. No. Somebody has one before and after, and that's not good. Are they, and I'm assuming, well, I should say, these are classes you actually have to tune into, right? That so there's no materials on Friday, so you should be okay on Friday. After should work. So if we go to 12:45, right, is that going to freak anybody out? So let's make it specific time. If we go from start at 11:30 and go to 12:45, is that going to be a problem with anyone? All right, Nathan's okay now after work. All right, if you've got a problem with going to 12:45, write it in the comments now or turn on your mic and tell me.
I've got a question about the interface you just described. So is it going to be like a submission opening up on Blackboard in addition to a, so there's going to be like a downloadable PDF with the long answer problems, and then there's going to be a like quiz type test thing where we just answer multiple choice questions in Blackboard too concurrently?
It's so the what I'm sure of is it could all be just a PDF you download, even the multiple choice, and then you upload your answers in. It'll look like a Blackboard assignment. So you have a box and you can select the file and upload it from your computer. That's if I've got enough time, I'll write them into Blackboard, the multiple choice, because then it automatically grades and so forth through that. And I didn't have time Monday to get the 354 class that way. So that was all just, it looked exactly like my normal test, except it was all PDF and everybody just downloaded it. The assignment opened up at the start time and people could download, and then they use the submit button to send their answers in or emailed me the answers before the end time. So it's at least that. And if I've got time, I would like to put them in Blackboard, because that saves me a lot of time grading, and you'll get your scores a lot faster, which I guess is either good or bad. I'm not sure. Whichever way you look at that, it could be good or it could be bad, right? It'll be good this time. This time it'll be good. Everyone will be glad to see their scores. So that would work faster if I can, but Blackboard takes forever to write the questions into the multiple choice format. So it's a lot more lead time on the front end for me. It's a lot faster on the back end and getting your scores back. And okay, one comment here: we'd prefer to have it all as a PDF. Yeah, okay, I can see that point. All right, let's just do it all PDF. It'll just be all one big file, and you can mark your scores down that way. I was thinking, like, I don't know if you guys ever used the Scantron sheets, which is just a page when you just, all it has is the A, B, C, and D on it. You just circle the letter for each problem. I wish Blackboard just had that, right? You could read the questions on the page and then just click over on the Blackboard one. But it's then again, if you've got intermittent internet at home, that may not be good, right? So all right, it'll be a standard. It'll look just like the other exam, except it'll be a PDF, not on real paper. So we'll just do it that way. All right. Thanks
so
for the feedback.
Any chance that could be a Word document so that we can like edit it in Word to turn it in?
Yes, it can be a Word document, as long as you don't change the questions. So, yeah. Let me write this down. Hadn't thought of that. All right, so we'll make it a Word doc. Good point. I mean, if I really had time, I could make you could do forms as a PDF, but we're not going to do that. All right, we'll make it a Word doc. Any other comments? I'm reading the comments over here. Yep, sounds great. Nope. All right, so I think everybody's agreed. We're going to go write this down too, so I don't forget. We're going 11:30 to, let's go 12. Let's go 12:55. How's that? So that's an extra 15 minutes to work. No, actually, class is supposed to end at 11 or 12:20. Let's go to 12:50. How's that? Split the difference. So that'll give you an extra 20 minutes to work and then 10 minutes for uploading and taking pictures. Does that sound okay? I mean, I suppose you'd vote for 3 hours, right? If you could vote, but unless somebody's freaking out, we'll go 11:30 to 12:50 then. Will be the official scale. If you've got an accommodation, if you want to send me an email, then yours will be due later. And so I'll set up the assignment that the due time is 12:50. It'll mark it late, but you can still upload stuff. If you've got an accommodation, don't freak out because it says it's late. Just go ahead and upload it, and I know who's asked for the use their accommodation, and I'll automatically add in the extra time for that. So, and it's like homeworks, right? It'll accept it if it's late. It just marks it as late, and I'll ignore that, right, when grading it. So if you've got an accommodation, if you don't have an accommodation, then I will not ignore it, right? So make sure it's in on time for that. Okay, any other general questions about format and style and time? Okay, hearing none, I will. So now usually if we were in class, I would ask you if you have questions, specifically things you had questions about from that you saw from the homeworks or the lectures lately. So is there any of those? Anything I can answer?
So this exam isn't going to cover things like TASs or like the Poisson probability of people taking trips and things like that.
No, right. That's all transportation demand modeling. We stop in chapter 7, which is signals. So the last week will not be on the exam. Maybe a little more than a week, but so it's just up through chapter 7, traffic signals. Other general questions? Okay. If you do, let me know. It's funny. I was trying to. Nope, no new comments. All right. So if you want, I can flip through here. Here's my review slides on that. All right. I guess since everyone is so quiet, I'm assuming that's a yes. We'll go through some of these, right? I'll give you some ideas about what I think were important. Feel free to turn your mic on and jump in at any point, right? If you suddenly have a question or want me to stop and explain something more. So let's, I will say this is a, just had a new comment here. Problems requiring calculation, water rounding guidelines. That's a good question. Cycle lengths, good question. Cycle lengths, your finished cycle length, I like to be to the nearest second. And I usually round green time, effective green times, if you're asked to do that, to the nearest second. For most things, I'm trying to think what else we did. Like the density. So if you're calculating levels of service, and if I were to ask you what's the lane density, V sub P, right? Equivalent density in, that's equivalent flow rate, equivalent density, 1 or 2 decimal places is usually fine. In this, it's not that exact of a science, right? For delay, if you're calculating delay and it's like vehicle average vehicle seconds or minutes, 1 decimal place is usually fine on that through there. And I'm trying to think what other kinds of problems we've got. Yes, you can ask questions about the project at the end. Optimal green time. The book says round up to 5 seconds, correct? I don't agree. I say round to the nearest 1 second. And I will try to remember, I'm going to write another note for that. And that was for cycle lengths is what they were looking for. The book says around 5 seconds, but I've never done that in practice. We always use to the nearest. And so I would recommend that, cycle lengths. I'll try to remember to write that if I ask that kind of a question. Round to nearest. I'll try to make that specifically say that in the question. Round to nearest second. How's that? Okay. Green time. Yes. Should we round between steps or wait until the end? Ooh, these are tough questions. I usually leave the decimals until I get to the end and then I round. And it shouldn't, most of the things we've been calculating shouldn't make a huge difference through that. And really, if you're carrying 2 decimal places until you get to the end, you'll be fine, right? Because then you can round effectively to 1 decimal place when you get to the end. And that should be good enough for trying to, this has rarely been a problem in these kinds of problems. And I know what the answer is when I'm grading it. And if I can see you just rounded, it's equal. I'll let it go. Like on the last test, I specifically said use 2 decimal places, for stations and elevations. In this case, in traffic volume stuff, usually 1 decimal places is fine for everything we do. If we're calculating cars links in storage, then it has to be an integer number, right? Because we can't have a decimal car waiting in, if I ask you what the probability, you can have decimals in traffic numbers, but if I'm saying how many cars can wait in a queue and I give you a specific length, then we round off to integer number of vehicles. And if you round up always in that, I don't think that's one of the questions we've been covering lately. I think that's the other class where we've been calculating queue lengths, and that would be rounding to a whole integer value for that. All right, other questions so far? That's good. All right. So the review, this is kind of long. So if you want me to jump to a section, write me a comment or turn your mic on and tell me, and we can jump through there. If you're getting bored, I guess if I see you all log off, then I'll know this is way too boring. And well, anyway, through there. I am recording this, so I'll post this in the end. Hopefully, I haven't done the recording on Google Hangouts before, but I think hopefully it's recording the screen because that's what I'm presenting, right? And hopefully you can all see that, right? Say I'm still, yep, I'm still as I'm presenting. Good. So we're in general, we're going to be covering traffic, queuing, levels of service, traffic signals. So it's chapters 5 through 7. It's open book and open notes. This is what I normally tell people. It's anything written, well, anything goes now, right? So I was joking with one professor is that, the Google searches for what's the effective green time will probably jump up during the test, right? Because whatever. Right? So you can use anything you got for that. That does mean these won't be super easy questions. I'll try not to be too rough because I know not everybody has their book with them. If you don't have your book, you can get a free version of it, an electronic version. I think I sent out an email about that a couple weeks ago. So Wiley has an option where you can get, actually it's through the Valpo bookstore, but there's a way to get a free version of that. So if you haven't done that yet, you'll probably want that just so you have a reference. So hopefully you've already worked that out. You've been turning homework since, so you must have figured it out somehow, right, through that. So you can use any electronic device you want now, because who knows, right? Now, just can't ask your parents, right? I'm not sure that would help you or not, but all right. We've already talked about it's going to have the short answer section, which is the multiple choice piece, and then it'll be longer worked out problems for that. Be familiar with where things are in the notes, and again, electronically you do have all the notes available. They're all posted, right? So I don't know if that's easy or not to use Blackboard to jump over there and find your notes. Maybe you want to download all the PDFs of the notes and keep them all in one folder so you can get to them fast. And do that. I'm guessing most of you aren't printing these out and keeping a paper copy at home for that. The same idea though is know where stuff is, right? Maybe have a quick guide on the side saying that if I want to know which lecture has this in it, the effective green times is in lecture number whatever, right? Maybe you want to do something like that, kind of like the virtual version of tabbing out your notes, right? So you can quickly find where stuff is through that. So just kind of run down by lecture number, maybe what's in each lecture for that. So again, that's the classic response about open book and open note things. It's more of a time test, right? That through there. And what does the fifth bullet point mean? 1, 2, 3, 4, 5. Is that the fifth including the crossed off one, or the fifth not including the crossed off one? Short answer section is what's that?
Say including the crossed off one.
Oh, okay. Thanks. Short answer sections, that's the multiple choice. And that's going to be the more concept questions. That's what that means. And so that'll be sometimes it's terminology, right? What does progression mean? What does permissive mean? That kind of thing. It could be concepts about what does it mean if you've got a level of service of that, or something, one thing or another through that. The dog came over. I had to pet the dog. Sorry. Does that answer that question? I mean, after the opening session, it'd be just like the last test. The first 10 questions, right? It'll be the same as that, and then it'll go into longer workout, more like homework problems after that. So does that cover the question there?
Yes.
Okay, thanks. All right. Moving on. So this was where we started. We did some traffic stuff. Not all of this is in the textbook, right? So check the notes from when we started this section. I thought the textbook was a little lax on some of their basic traffic. We jump into traffic flow theory stuff, but they didn't always cover the basics right off. So this may be more out of the notes through there. So our K factor was our peak hour factor. So it's technically is defined as the 30th highest hourly volume through there. The D factor is watt proportion. It's our directional split factor. It's what proportion is going in the predominant direction. And so in the morning, it's usually headed into town. In the afternoon, it's headed back out of town. All right. So that's what the D factor is. And it's either a decimal or percentage. You can write it either way. So it's either 0.56 or 56% are going in the predominant direction. That'd be a normal D factor. For that. And then directional design hour volume, DDHV, we call that. That's what we would actually design our traffic signals for, would be a directional design hour volume. And we also, for our capacity on a road, we'd use that directional design hour volume. So that takes into account which direction is predominant at the time, and which direction you're moving through, right, for the time. And so that includes that directionality factor as well as that peak hour factor. So it's the amount of traffic going in the predominant direction during the peak hour. How's that? And we'll see the equation down here. And that's exactly what this equation gives you. This is your peak hour factor, basically. This is your directionality factor, and here's what your average annual daily traffic is. And that gives you your directional design hour volume. That's what you'd actually design that direction for, or your road for, when you're doing design, both for traffic signals, for geometrics, and all of that. Right. So it's just K times D times A dt. Right. And this would be a pretty common kind of a question, is I give you a bunch of traffic numbers and you've got to calculate all these things out of that. All right, so out of this, what's the peak hour? All right, so here's left, through, and right. This is just for westbound traffic, so maybe I'm just looking at one direction. Here's the total of those three columns. All right, so that's the total volume in that direction. So where's my peak hour? What's my peak hour factor, right? How would you calculate that? And we do it by 15-minute bins. And so this is the start time of that 15-minute bin. So there were 7 cars between 6:30 and 6:45. That's what this is telling you, all right? And so if you add 4 of these together, that would be an hour. So that's how I would normally do it. We do an hour. I do a rolling total, right? This 276, if we checked it, it should be adding together all the 4 of these things. That's your 276. 294 starts at 66, 66, 89, and 73. That should be 294. So you can see it's this one plus the 3 before it. And that'll be that hour. And it's technically, this is the volume in that peak hour ending at the end of this interval. Is that one way to look at it? And we get confused. It's common to get confused kind of on, well, this says 7:15. Some people say, well, the peak hour from 7 to 8, I'm going to add together these 5. Well, that is incorrect. Right? This is the start time of the interval. For a peak hour, you'd add together 4 of them, 7 to 7:45. The 7:45 interval ends right at 8. And then the 8 interval starts right at 8 and moves forward, right? So it's 4 of these together. Don't do 5. That's been a common problem in the past in reading these charts, right? And so if you add these together, this number is those 4. This 294 is 66 through 73, and so forth and so on. You quickly figure out then, well, what's the biggest one in here? It's this, right? And so here's our peak hour. Our peak hour ended in the 8 to 8:15 interval. So this starts at 8 and ended at 8:15, and it's these 4 before it. So our peak hour is 7:15 through 8:15. That would, if I ask you what the peak hour is, that's what it would say, 7:15 through 8:15. And that's what the total number in that hour is 383. All right, so that's the peak hour. The peak hour factor, right? Remember we worked on that in levels of service as well. So sorry, the scanner is going off. I'm listening to where the ambulance is going. Okay, peak hour. See how less productive I am during when I'm staying at home. So the peak hour is 7:15 to 8:15. In here, our peak 15 minutes out of that peak hour, right? The peak hour ends on this interval. Our peak 15 minutes is 1:17. So there it is. And the peak hour is 383. We can do that calculation. All right, so we take the total number of vehicles that have passed during the hour divided times the peak, and that's our peak hour factor, 0.82. That's a higher peak than normal. You know, what's our normal peak hour factor? Anybody want to write in? A normal factor would be more like 0.9, 0.92, right? Do that. So that's a normal peak hour factor. And that's for a single approach. You could also do it for all the approaches on the road and combine them all together into all four approaches. It's a standard intersection. And you could do a peak hour factor that way. You could also do peak hour that way as well. All right. So so if we have the eastbound total vehicles during the same hour is 297 and our average annual daily traffic is 8,500, what's the K factor? All right. And so that would be, if it's a two-lane, if we're just looking at a road going east and west and not at an intersection, we would take all that traffic together, right? That's our peak hour in both directions and divided by the T, and that would give us a peak hour factor of about 8%. All right. The total volume on that road during the peak hour is about 8% of the total for the day. And that's a pretty common number, 8 to 10%. It's pretty common for that. And let's see what's the next question. What's my directional split? All right, so I've got 383 in the primary direction or the predominant direction. I've got 297 in the other direction. What's my directional split? All right, so we can do that math, right? About 56% is where we would have it. Right. And the question, what would I show in this case? Because we often convert this number into a percentage, I would use 2 decimal places. That's kind of a question from before. How many decimal places to show? For D, I would probably, and K even, I'd probably use 2 decimal places because we often convert it into a percentage. And so if we ever did that, we'd want 2 decimal places. It doesn't help much to go past that, really. So a whole percent number or 2 decimal places, if you want to use decimal, will be good enough on these for that. Right. What's our directional design error volume now? If we went through that, we're just going to take K times D times the ADT, and that would be 382.84 in this case, would be our directional design error volume. So we're just using that equation then, right? And does that number sound familiar? Well, I hope it does, because that's exactly what this is, right? So that's the little trick, right? Your directional design hour volume, if you know what your peak hour is, and you know what out of that day in a single direction, your peak hour in a single direction, that is your directional design hour volume. That you should get that number back, right? You should come right back to that number if you already started with that. So that's sometimes a tricky question, right? On there. Then from there we moved into flow rates, right? And so flow is just the number of vehicles per some unit of time. So you're dividing the number of vehicles per some unit of time. We usually report those in vehicles per hour. That's our standard. You can report it in anything, vehicles per second, vehicles per minute. Vehicles per hour is kind of the standard we use, right? Even if we measure it for less time, we measure it for those 15-minute intervals, we'll often report it as so many vehicles per hour. That's our normal. For that, density is the number of vehicles per some unit length. And in this case, our unit length is usually miles. So we're usually reporting density in vehicles per mile on our roadway. And remember, that's our key indicator for levels of service, is how many vehicles per lane per mile. And that density is what we're usually looking for. Sorry, the ambulance went by. I have to peek out the window and see what they're doing down there. So, all right. So see, this is exciting, working from home. Maybe not. So that's our density, is just number of vehicles per some unit length. And we typically report that in per mile. And when you did all those level of service calculations, remember, it was always per lane, number of vehicles per lane per mile. That was our standard for measuring that. That was our standard metric for level of service. Right, above a certain density, then you're in a different level of service. Flow rate, you can also say it's the flow rate is the speed times the density, right? If you can work that math works out. If you're reporting in miles per hour and vehicles per mile, then you're going to end up with vehicles per hour. So you're going to get flow rate, right? So they're all connected. They're all work back and connected. We've got these basic equations. You know, if you've got density, we're just converting how many in density, if we know what the spacing is of our vehicles in feet per vehicle, and that's the space from the front bumper to the next front bumper, all right? If we know what that spacing is, we take how many feet per mile divided by that, that'll give us density. If we take spacing in feet per vehicle divided by feet per second in speed, we can get the headway. That's how much time between the successive passes of the front bumpers as they come through, right? So seconds per vehicle in the headway. And then finally, a flow rate, if we, and this is assuming headways in seconds per vehicle. If you take 3,600, how many seconds are in an hour divided by seconds per vehicle, that'll give you a flow rate in vehicles per hour, which is normally how we want to read it, right? That's our standard unit for that. So everything's interrelated and everything's connected. So just to keep that in mind. You can, if you're getting one of these things, you can usually get to the others from that. And those are pretty common test questions to go that way. Just remember the models are all tied together. All right, so our speed and our density is also tied together with our flow and our density. And our flow and our speed is also connected to speed and density. All right, that's the Greenfield's model, we say. And it's the classic traffic flow theory. These things are kind of tied together, right? At low density and high speeds, we have a very low flow rate. A low density and a high speed over here as well. The flow rate's showing as very low. So it's high speed and a low flow rate. It would be on this graph, right? Through that. As we move into the middle, we've got a middle speed and a middle density that would give us typically the peak flow rate. And we can see that over here too. That's the peak flow rate. Now down at this end, we've got a really high density but very low speed. This is a traffic jam, right? And with the traffic jam, you've got a very low flow rate because people just aren't moving through that. And over here, you can see the same thing. Traffic jam, you've got low speed and also the low flow rate on that. So they're all tied together. Keep that in mind. We went through Poisson assumptions, and for arrival rates, typically at traffic signals is where we use this the most. Through there, Poisson assumes vehicle arrivals are random and that there is a constant rate in the background that you can analyze it for through that. So that's what Poisson is looking at in any one of these intervals. That's what each of these boxes are. Now we can calculate what the probability of having 2 vehicles arrive or 3 vehicles arrive or 1 vehicle arrive. We can calculate that probability. And this is the Poisson equation. Lambda is your average rate. T is the time interval you're looking at. And then N is the number of vehicles you're looking for that arrive during that period. So I wanted 2 vehicles in a 60-minute period. T is going to be the 60 minutes. N is going to be 2. Lambda is the average arrival rate, which should match those units. So vehicles per minute. Do that. And then e to the negative lambda t and divided by n factorial. So that'll give you the probability that 2 vehicles arrive. Right? And that's what we're using. You can do a graph like this then saying what's the probability of no vehicles arriving, given us current some average arrival rate, 1 vehicle arriving, 2 vehicles arriving, 3 vehicles arriving, and so forth. You can calculate that, right? And so for this this is a fairly low arrival rate, right? 1 or 2 vehicles arriving during that 20-second time interval is going to be the most common through that. And the way we use this is when we're designing traffic lanes through there. I can see that. Yeah. Coming up, we can do these cumulative plots like this. So we're actually adding these together to get a cumulative number up to that. So this is the probability of 3 vehicles arriving. This 1% is the probability of 0 through 3 vehicles arriving. Right. So it's a cumulative percentage. But we try to, we'll design for a percentage. Maybe we want 50%. We want to design for the average arrival. Or more commonly, we go for the 85th percentile. So 85% of the time we have enough space for all the vehicles to be there. In this case, we'd have to allow for 13 vehicles to arrive. This is where we'd want to have an integer number for that, because we're going to design this lane to handle 13 vehicles. It doesn't help us to design for 12.9 vehicles, right? That doesn't help. We just have extra. We have 0.9 extra space that no car can fit in, right? So we'd run around that up to the next larger turn lane size, and it's something you'll be doing in 354 next year if you take Transpo 2 through that. So this is where we use Poisson mostly. Is now we can figure out what's the cumulative percentage. What it's kind of like what you return in your storm you're looking for, right? Do we want to be 85% confident we can handle as cars as we need, or do we want to be 95% confident? For NDOT, they do their traffic analysis more based on, they want the 95th percentile. They don't want the 50th percentile. They want 95% sure that you have a long enough turn lane. So that's how we use Poisson. This is assuming random arrivals and assuming you know some average rate during this time period that you're looking at, right? And those average rates change during the day, obviously, through that. So that was Poisson. Again, I'll flip. Sorry, I was looking. Send me a note or just speak up if you want me to stop, and if you have questions about any of this stuff, or if you want me to skip ahead. I'm happy to do either one. So we talked about queuing. There's a lot of different kinds of queuing. We only ever looked at DD1. So it's a deterministic arrival, deterministic departure, and a single queue lane, typically through that. And that covers the basics enough. Sorry, I got out of Word. There we go. So this was our graphical presentation of this, right? And probably giving you flashbacks of horrific homework assignments, right? I think this was right before break we were doing this. This was, well, we're still on break, right? So this is right before the official spring break. We were doing this as our time. In this case, we were using minutes down here. When we see the same kind of graph later for traffic signals, this is often in seconds. It can be either one. Just keep in mind what units you're using for it. So here's our time in minutes. Here's the number of vehicles that have arrived. So at 10 minutes in from the start of some event, right, from zero time, 10 minutes in, this many vehicles, we plot up here on the vertical axis, that many vehicles have arrived, right? At 20 minutes in, we've had 160 vehicles have arrived by now, right? And for that, you can also look at the other way around is, well, at 240 vehicles in, how long did it take for 240 vehicles to get there? And you can plot across this way, 60 minutes, right, for that. So it's ways to read this chart. We have an arrival rate, which is usually this side of the graph, right? And I can flip through here. Here's our arrival rate. If we know what our normal arrival rate is, at some point in this example, the arrival rate changed, and so it switched to lambda 2 through there, so that we have a different arrival rate at that point. We have a single departure rate. We're processing people through. Maybe this is a toll booth. We're processing people through at the same rate, so that's our mu through there, and so that stays constant, right? This could be constant. The arrival rate could be constant, and the departure rate could change partway through. It doesn't have to always be this kind of a shape through there. They could both change. They could both change partway through. Suddenly, the people processing the toll booth got faster. That'd be that example we went through. All right, so that's where we are there. Make sure I'm not missing any comments. Nope. All right, so we're that's what our arrival rates are. And if you pick a line in here, I don't know if that's coming up. The vertical difference is how many people are waiting in line at 10 minutes in. So if you pick a certain time during this whatever's going on, right, this arrivals at this toll booth, the vertical line is giving you how many cars are in that queue. Right? If you take the difference between the total number of cars who have arrived minus the total number of cars who departed at 10 minutes in, the difference is how many people are still waiting, right? And so the longest vertical line gives you the longest queue. That's kind of a key point in here. The horizontal lines are telling you how long some vehicle waited. So vehicle number 100 waited from this start time to this time, right? So if you can plot down here what that time was they arrived, and then you plot what time they departed, that horizontal length is how long the vehicle waited. in line. I think that's actually this next slide. There we go. All right. So that's that'll give you the delay, and the longest horizontal line is the longest any one vehicle had to wait. So that's your longest vehicle queue delay. Right. And where we want to end up with is if you take the area of that triangle or any shape, depending on if you've got a more complicated shape, depending on your arrivals and departures, if you take the area of that is giving you the total user delay at this toll booth or traffic signal or whatever it is, we can calculate the total. We can calculate the total user delay of that whole process, whatever's going on. Could be an accident and the road is backed up and lanes are closed, until they clear that out. Right. So that's whatever it is. If we added this up, this area under here, that'll give you vehicle minutes of delay. Right. So you're taking this axis times that axis, basically. So it's vehicle minutes of delay. And then we showed in traffic signals, you can use this exact same thing and calculate what your level of service is for that one approach or for the entire intersection, if you're plotting the entire intersection. Right. So there's our delay piece. For there, what could I ask you is what's the maximum delay to a single vehicle? Well, how would you find that out? All right, well, that's over here, and that's that longest horizontal line. Sorry, the mailman's walking by, so the dog is barking. Yeah, he's pretty. That's his one job, is to protect us from mailmen and cats. What time is the queue going to dissipate? Right, that's a great question. That's where these points cross up here. Right, so where the triangle ends, that's going to be the point of dissipation. That's where, yeah, he does have opinions. So that's where the queue dissipates, right, where these come together. And maybe sometimes they don't ever dissipate. We can write it that way, and then you'll just have to cut it off at a certain time and calculate the delay up to that point. Right, for that. When does the 60th vehicle arrive and when do they wait? Right, so you're going to have to figure out where the 60th vehicle is here and plot it across. Goes through. If a vehicle arrived at 28 minutes, yeah, he's very active. 28 minutes, how long is he going to wait? That vehicle going to wait through there. So those are all kinds of questions we can pull out of this stuff. Your dog, yeah. Oh yeah, no, it's the mailman. That's the mailman right now. If there was a cat, he would also get super excited. And the mailman, there he goes. He's going to the other window now. What do you see, Cash? He also hates UPS trucks, but cats are his number one enemy here, and they'll wander past our yard and sit in the front yard for a while. And yeah. All right. Okay. That's delay calculations. That was probably a little more involved as far as calcs went for a lot of the stuff we've done. Level of service started out easy, and then it got hard when we got the two-lane roads. That was the hardest piece, right? Through there. Freeways, in hindsight, wasn't that bad, right? So we can calculate the level of service through that. The workflow from there is you want to know what your free flow speed is. Either you're told that or you can estimate it. There's an equation for estimating. Yeah, mute the dog. I should. Cash. Oh, he's got his bone now. I think he's okay. Are you okay? All right. Anyway, whoop. All right. He's after he gets a little energy out, and then he usually lays on the floor and sleeps for a bit. So we'll see. Oh, yep, there he is. He's going down. All right. The site was passed. So then. So you're going to have an equation, or you're going to be told what the free flow speed is, right, through there. And you can calculate free flow speed. Remember, that's all that stuff about, well, if you don't have enough shoulder room or your lanes are narrower, so forth and so on, that's where that comes into the calculating your free flow speed through that. Next up is what's your heavy vehicle factor. You'll be told what your percentage is and whether it's rolling or a flat level ground, and from that you can calculate what your heavy vehicle factor is, right? So trucks and buses and RVs are taking up more than their share of space, right, in flow terms than what a passenger car would be. So we're going to convert the number of vehicles, heavy vehicles we got, into an equivalent number of passenger cars, right? So they're equal to maybe 2 or 3 passenger cars, or some percentage of that through there. Your peak hour factor, that's usually given, but you know how to calculate it. Right? We just went through that, how to calculate that stuff. Then you got to calculate the flow rate, right? And so that's at V sub P is where you want. That's the equivalent flow rate of passenger cars per lane through there. Once you've got that, we can calculate then what the level service is for that. And V is your total volume, but that includes trucks and odd-sized vehicles and all that. That's just a number of vehicles who pass at any one point. We convert V into V sub P, which is the equivalent flow rate. And that's why we need to know what that heavy vehicle factors are, right, through there. And V sub P, once we've got it all apples to apples, basically, it's all in passenger cars, then we can calculate level of service. So that's our flow system through that. And I see we're out of time. Sorry, 12:20. I'll continue on if you guys want me to. And if you've got places to go, feel free to log off at any point. I am recording this, I think, so I'll post the recording later on that. So you can catch up if you had to go somewhere. All right. A lot of people are dropping, so you must have a class right now. So you can calculate the heavy vehicle factor. All right. Traffic signals. We're going to want to know what the cycle length is, what progression, offset, and these are terms. So be familiar with what these terms are. And this would be probably more on those multiple choice questions toward the beginning. All right. So know what those terms are. And some are pretty obvious. Permitted, permissive, we talked about a little bit in one lecture. We didn't do a lot of it in there, but what is that? What's a phase through that, right? A phase is anything that's timed together on the signal. So it's often like a left turn lane could be its own phase, or a left turn lane and the through lane could both just get a green light at the same time, and it'd be a phase together if there's no arrow. Right, so that's what a phase is. It's the phases make up an entire cycle within a traffic signal. So there's your phase. If you don't get an arrow, then it's a permitted or permissive left turn. Right? That's what those mean through there. Effective green and red, you don't get to use all of the green time or what's programmed as red. The effective green time is less than what the actual green indication is on your traffic signal. The effective red time is larger than what the red symbol is on your signal, right, through that. Offsets are for progression, and that's when you have coordinated signals through there. And I think I may have a question come up with that, right? We talked about different forms of vehicle detection, so that's a good exam question. Is yes, I can, Andrew. What is the what is commonly in use now for vehicle detection besides my dog, who detects vehicles as well? All right, he hasn't got a job yet for the city, so right now we're using loops. We've got these little magnetic pucks you can put into the pavement. We use video systems. We use thermal systems. All those. So we talked about, there was a whole lecture, I think, on detection. So that could be a good multiple choice question, right? Probably which of these aren't being used currently for vehicle detection. Saturation flow rate, that's if the light was green all the time, how many cars could come through that lane if it had for an hour, right? And again, we do flow rates typically in vehicles per hour. So that would be our saturation flow rate. It's quite often, the perfect fast flowing lane is going to be around 1,800 vehicles per hour. At a signal, we don't usually get that rate, right? It's going to be more like 1,200 or maybe even 600. Because if you're turning left or turning right, you're going to be moving slower. We don't get as many people through. All right. So there's a saturation flow rate. If I tell you what the headway is, right? If it's 2 seconds between vehicles, you should be able to calculate what the saturation flow rate is. If I tell you the saturation headway is 2 seconds per vehicle, and then you should be able to back calculate what the flow rate is from that. Lost time is exactly that time we lose within the cycle. And the first 2 seconds in green is lost time. The last second of yellow is lost time. And then the all red, no one's moving during all red. That's all lost time. Right through there. You can calculate it per lane or per phase, and then you can add it together to get total lost time during the cycle. And that's what we use in those equations for the optimal cycle length and so forth, right? We're going through that way. And then what's the capacity of your lane or your phase? And then our critical lane group would be those flow ratios. Which one is closer to your capacity? which is the volume of cars you've got divided by the saturation rate. So that's your critical lane group saturation. Do that. All right, here's the equation for the minimum cycle length. And so this is total lost time during the cycle. So that's the lost time for each of the phases added together. So it may only be 4 seconds of lost time per phase, but you got 4 phases. This is 16. Right. This X sub C is your critical volume to capacity ratio, and you usually pick that. And if you want it to run at capacity, this is 1. If you want it to run less than capacity, you're going to pick 0.8 or 0.9. And we'll probably tell you which one to use. You don't have to guess on that in the problem statement. We tell you what you're aiming for your critical volume to capacity ratio. Typically 0.8, 0.9 would be where we'd want to be on this. Right, we don't want to be at 1. that's technically, if you have a volume to capacity ratio of 1, your level service F. It's your intersection. So no, we don't want to use 1. The book was a little more generous about you could use 1. I'm going to tell you, you don't want to use 1 unless you have to. If you're out of time and you can't do anything better, then maybe you've got that. Right. And this is the individual lane group. It's kind of the same idea of volume and capacity. This is your volume to your saturation rate. This is your critical factor for that phase or that lane group, right? So if you're through in your left movement or timing together, but the left turn has a higher V over S ratio, that's going to be your critical one. And then for each phase you've got in your signal, you add those together. And so if you've got 4 phases, you'd add 4 of those critical factors together. And that's capital Y is also what they use in the book for that. All right, do that. And make sure I'm not missing any comments. Yes, all right, yep. I did not miss any comments. All right, still got a few of you with us, right? So I'll keep going, and I will post all this in the end. Allocating the green time. Yeah, so your effective green time is what you're actually allocating. You're taking that V over S ratio for that critical lane group in that phase. So this is the green time for a certain phase. Here's the critical V over S ratio for that phase times C over your volume to capacity ratio for that group. So C over X sub I through that. The book is, when they did theirs, you calculated this cycle length back here, C min. I missed the slide. Oh, there's C optimal. All right, there's a C optimal in there as well. Whichever they want you to do, use the minimum or the optimal cycle length time. Then they round it, right? And then they recalculate their X term before they use this equation to allocate the effective green time. So if you round it up 5 seconds like they want you to, which I don't want you to, this may change a fair bit, a tenth or 500ths or so. And so that'll make more difference, right? If you're rounding to the nearest second, it's not going to make that much difference through there. But they add that step in their solutions for their homework problems, which reminds me, I'll write that down. I don't think I've posted all those homework solutions yet. So I will get on that, as well as the ICAs. And I think I turned on, if you go back to the quizzes you've taken and the ICA quiz or answers in Blackboard, if you go back to them now, once everything is graded, they're supposed to show you what all the right and wrong answers were again. All right, so I didn't have that turned on originally. I think I turned that on last night. So you can go back and see those, see what the correct answers were. And you can also see what you got on them too, but at least you can see the correct answers for all the ICAs and stuff that have been on Blackboard and quizzes. Right, do that. All right. See optimal. Whoop. Right. Through there. Here's our effective green time allocation. Right. Through that. And that's, you're taking the critical lane movement ratio times the cycle length divided by what your preferred, your target V over C ratio is. And that's what we've got there. All right. And then finally, we have delay per cycle through there. Oh, everyone must have a class. I'm losing you all. This was the last piece. We were right back to that. Here's during our red phase, our green phase. You can see where people have to stop and then go again. It's exactly like we did before with delay. If you calculate the area inside these boxes, you can figure out when the delay is. If you can calculate where this point is, you know at what time the queue emptied out, right, and so forth. So we can use it the same way as we did before that. Samples questions that you might see for signals is calculate the minimum cycle length, the optimal, what's the effective green, what's the green for each phase, right? That's a pretty common question. What's our average vehicle delay, right? If we know how much green time and red time we've got and what the average rate of vehicles are at arriving, this is their arrival rate. And then this is that saturation flow rate on this backside. That's departure rate is saturation flow rate. And so you should be able to develop and figure out all those pieces, right, and calculate that all through there. And then finally, what's the offset? And we did one quick question on that, which was calculating the offsets, which is just the distance divided by the average speed between signals. Right. So if you've got 2,000 feet between signals and cars are going 45 miles per hour, you need to be able to convert that first to feet per second. So convert your speed to feet per second. And then you just divide that distance divided by the speed in feet per second. And that'll give you how many seconds of offset you need for your coordinated cycle. Right. That was all I had for comments. So it's up to you guys now. Since I've lost you all, so you're on the class. Ooh, right at 12:30. That's not too bad. Full straight up hour. Right. We would have made it if we didn't have the dog barking in the background. So any other questions you guys have for me? All four of you who are left. So. All right, last chance. So I will post this recording, and then I will also post these slides so you guys can flip through them and see. All right. Not hearing anything, I will stop presenting, and I guess that'll be it. I'll see you. If you have other questions, you're welcome to send me an email, and that'll be it. Thanks.